Okay, folks, we'll get going. Again, this is Steve Yolga. I'm the Director of Sales and Marketing with DoALL Sawing Products, and we want to thank you for taking some time out of your day today to learn more about our products, our saw blades, and our circular saw machines. Today, we are fortunate to have Tim Piehel, who has over 35 years of experience in the sawing world, specifically sawing metal world, to join us today and share some of his tips and tricks of the trade with circular saw blades and learn some of the basics, or teach you guys some of the basics. I want to remind you that you all can ask questions through the chat function. So if you do have a question, please throw it up on the chat and we'll try to get to those at the end of the presentation. Without further ado, we're going to hand it over to Tim. So here you go, Tim, and thanks again, everyone, for joining us.
Good afternoon, everyone. I'd like to welcome everyone for attending our webinar series on sawing. Today, we're going to cover our circular saws and our blade lineup. Circular saws are becoming more popular than ever due to the increase in production you receive over a bandsaw. In small materials, a circular saw will replace 2 to 3 bandsaws. One big advantage on a circular saw is, like, if you're nesting on a bandsaw, you normally would take this bundle of material, have to put it into a bundle, put it into place. Once you get it, so you may strap it, you may not. And then the other thing is you start cutting, you got to lower your your feed rates and stuff because of the bundle. And then you get the spinner in the middle and there goes the blade. The advantage on a circular saw is you have a bar loader, you load everything on the table, and it's lights out. There's no having to sit there and bundle and worry about stripping out the teeth on the blade. So we at DoALL here offer 3 different models of machines. Basically, we start with our SC75A. This is a 3-inch capacity machine. Our next unit that we offer is the SC100A. This is a 4-inch diameter machine. And then we have our big brother, which is the SC150A, and that is up to 6-inch capacity. So that's the lineup of the 3 saws that we currently handle. If we look at the specs on the SC75A, when we're dealing in circular saws, we talk a lot in millimeters, not inches. But basically, if you look, it's 3-inch capacity. It uses a 285 millimeter blade. It has a 15 horsepower motor on it, and you can see the blade speed is 30 to 150 RPMs. Most of these saws are made for cutting cold rolled carbon up to stainless steel. They're not really designed to cut exotics like Inconel, Hastelloy. When you look down here at this 30 band speed, blade speed, it's not going slow enough for you. So that's the specs on the SC75. We look at the SC100. Now we're going to a 360 millimeter blade. Again, 15 horsepower, and our blade speed is basically the same. Your stroke, this is your indexer. This will do a 24-inch stroke, but it will do multiples in indexing. When we get into the SC150 now, and we look at that, you're up to a 460 millimeter blade, but we're jumping up to 25 horsepower because we're cutting that 6-inch material. Our blade speed is running from 3 to 150, and our stroke is still 24 inches. But something to make you aware of, if you look down here and you see your minimum, this machine will not go all the way down to 0. So you're starting at 2.76 and going up to 6 inches. So if you're cutting, say, a 1-inch round bar, you just cannot do it on this machine. But if you had 1.5 inch round bar, you could actually cut 2 at a time with no problems. You also will see your rectangular dimensions on the spec sheet if you're not cutting rounds and want to cut squares or rectangular material. So we look at standard equipment. Some standard equipment that you want to be looking at is basically, they're all programmable logic controllers. Your head that's doing the cutting is controlled by a servo-driven ball screw. So there is not really any hydraulics on this machine. It's mostly done through servo motors and ball screws. Split front vise clamping is on this. We're clamping the material in both sides of the blade. They do have variable vise pressure on there. They also have adjustable carbide face blade guides, and we'll talk about that a little bit later. Another big thing is you do have high pressure air mist lubricator system. They don't have flood coolant. We're using mist system, and I'll show you that a little bit down the road. The other big thing is you have an electromagnetic power brake on it. What does that mean? We're actually got this braking system that's onto the motor, so we don't get, back whine or anything, that we get a constant tooth load onto that blade. Very important that that feature is there. So let's take a look at the SC75. As I talked about the bar loader, you can see here on the bar loader, basically you'll load your material on the bar. It will take 1 bar or even 2 bars, move it into the indexer at a time. So basically you can put a whole day's work, stack up your pile of bars and run this lights out, even if you're doing a nighttime. This unit right here, this is where you take and adjust for what width bar you're picking up and moving on to the bar loader. Now, if we look at the SC150, you got to remember, now this is our big brother. This is cutting the 6-inch. We use a little different bar loader. It's a lot heavier duty because we have a lot more weight when we're sitting there with the 6-inch material. So when we get into the looking inside the SC75A, basically one area I want to point out is if you look at this is a blow nozzle. So what this does is shoots a blast of air. So at the end of the cut, when the vise is opening, before we start indexing, we're shooting air to blow all the chips out of the way, make sure we're not going to have chips that we're going to clamp on, make sure we don't have any chips around the blade area that we're bringing back into the cut. A very important feature on a circular saw. When we talk about the mist unit, if you look up here, you're going to see missing hoses going everywhere. It's very important that you're putting a lot of lubricant at the proper places where it's needed. We individually miss every saw guide. And this thing actually has 4 saw guides under this door cover. The other thing you'll see, your band brush is power driven, getting those chips off of the actual blade. Here you can see our data screen with the working parameters. So if I look at this basically, and this will be on all the models, if I look right here and I see the 6.30, that is actually telling me what my length of cut is. They do have an amp gauge on, so we can see what kind of amperage it's drawing. If you look here, basically, we had 150 pieces. It's programmed to cut. Right now, we're cutting 27 pieces we have cut. This particular saw has your cutting rate, which is inches and seconds. So we're saying that head is moving 0.375 inch per second of movement on the head. Our blade speed is 140. We have an amp setting, so as the blade wears, we can set the amp so if this exceeds 17.5 amps, the machine will shut down. So if a blade goes bad, it's going to draw more amperage right away and shut the machine. Here's your cutting time. I don't know what diameter this was cutting, but it's cutting one part at 3.3 seconds per cut, and the whole cycle time from the time it starts into the cut, back out, and into the next cut is 9 seconds. So we're producing a part every 9 seconds. And here's your tooth load. You can see this is a very important knowledge that you need to know when we start talking circular saws. On this screen, you'll see our operation switches. So basically, if you look at the switch here, this one is able to move the indexer forward and back. This switch here will move the head back for easy blade change. This one here is clamping your vices. This is your back vise. This one here is your front vise. We have the auto and manual, so when you switch in auto, it just keeps running. Or if you're only going to cut one piece at a time, you can do it in the manual switch. This turns the cycles on and off. And of course, you have the emergency stop switch if needed for safety reasons. When we look in the back side, you'll see the vertical horizontal hold down. So what this is basically doing, when a bar comes into the loader, into the bar loader, onto the conveyor, it locates where the indexer will come back, grab the part, the bar, move it into a position. This will come down, hold it, and then the indexer will clamp to open, relocate, and whatever you have set for your actual cut off, your part, your crop end, your beginning part, say you only want to take and do a crop cut of like 3/4 of an inch or 1/2 an inch. You set that and it will bring the material right into position, ready to go. So that's what that mechanism does. We have this chute, and the chute goes left and right. This is your discharge. So basically, what we can do is we can do your trim cut, and we can do your remnant leftover pieces can drop in a different basket than your good parts that you're cutting. So we can separate the parts automatically. The chip conveyor is a chain style chip conveyor, and you're basically using that so you're able to move. We're creating a lot of chips when we're in cutting on the saw. So it's a chain style. If you actually look, this is your indexer. You're going to see the indexer moves on two chrome hardened rails, and it is controlled with a servo driven ball screw, which you can see here in the middle. So there's your chrome rails with the ball screw. So basically now that's our saw lineup. And now we're going to go in and kind of look and see our lineup of blades. We have a full line of circular blades that will fit all different manufacturers of saws. So, our blades will go for many different saws out there in the market, just not DoALL. So our DoALL circular saw blades are designed for use in high-performance circular saw machines. So basically, some of the blades we have a Cermet tooth tip, and we also have a tungsten carbide tooth tip, which are coated. So those are two styles of blades that we have. The other thing that's very important about our blades, if you see right here, our tight tolerances on our body flatness. This is important because, again, we're holding this blade between many pieces of 4 different carbides, and it got to be a perfect fit. So if the bodies that you're buying is just, they're not flat, there's differences, it's going to create all kinds of problems and give you poor blade life. As you see down here, the application is basically carbon steels, alloy steels, stainless steels, bearing steels, and tool steels. As you notice, we don't talk about the exotics, the Hastelloy, the Waspaloys, the Inconels. Those type of materials are not well suited for circular saws. So that's more of a bandsaw operation that you would be doing there. So we use different type of tooth materials and different series of blades. So the first we use is a Cermet. And Cermet we mostly use in low carbon. When you're cutting low carbon materials, Cermet is a very good way to go. It's a little lower in price than coated carbide. But then we also get into, depending on the type of blade, the series of blade, we use the P grade and we use the K grade. Most of all of our coatings that we use standard is a TIAIN coating on the blades. So let's look at a blade. There's a lot of information you need to know to be able to order and get the right blade. The first dimension you need to know is this A dimension. That's the diameter of the blade. And you'll see, I showed you the S75 had 285. The 100 have 360 millimeter blade. So we need to know that information. The next information we need to know is your borehole. What size bore? Different machines use different boreholes. So I could have brand X and brand A, both using 360 millimeter blades, but have different boreholes. The next thing you need to know is your pin sizes. This is your pins. What diameter pins do you need? That's an important measurement we need to know. The next measurement, the distance between the pinholes, which you're going to see that item D on here. We need to have that information. The other thing we need to know is how many pinholes and also what our body, and that would be G. What's the body diameter on there? Because, like I say, we're holding that blade in between inserts, so we need to know that measurement. So those are information required whenever you're looking to order blades. For example, if we look at our part numbers and our specs, take this top one. The first number here, 285, that's the diameter of the blade. The next dimension, 2.0, that's the curve. That's going to change with series. That one you don't really know. We're going to tell you what that is. The 1.7, that's that body thickness. Very important. Next number that we see here is 32. That's the bore. That's the bore in the middle of the blade. The next dimension, 4. That's telling me there's 4 pinholes in that blade. The next dimension you see there is 11. That is the diameter of the pinhole. The next is 63. That is telling me the spacing between the 2 pinholes is 63 millimeters. And then the next dimension is how many teeth are on the blade. For example, this would be a 60, what we say a 60 tooth blade. Okay, so that is information. That's when we look at our specs to see exactly what the right blade is spec'd out for you. So let's look at some charts. We have all these charts available, and I'll talk about a little bit. But you remember I talked about series of blades. So we have the IW01 all the way down to our IW-07 series blades. So we look at the tooth type on an IW01, you'll see it's a Surdman. If you remember, that's, what we showed earlier. And if you look over here, this is your percentage of carbon. So anything from a 1.1 to a 0.5 low carbon, that'd be like 1018 steel. You would use an IW01 blade. But now, for example, if I'm cutting stainless, I come down here and find stainless and shoot across. There I want to use the IW04, which it'd be a K-type material, tooth material, but it's also a coated blade. So by this chart, you can pick out the type of steel you're using and then be able to come over here and pick what series blade we recommend. If you look down below here, you will see the different brands of machines that our blades we offer, and there's some other ones that might not be on this list. So the next thing we're going to look at is looking to see what different pitch or what teeth, for example, a 60 tooth blade. Okay, there's 60 teeth into that blade. On this 250 millimeters, if I'm cutting 1.5 inches up to 2 inches, I would want to use this 60 teeth blade or a 60 tooth blade. But if I'm cutting the same 1.5 inches, but say I come down here and I have a 360 millimeter blade, that same material, you're going to see I'm going to want to be using a 100 tooth blade. So The diameter of the blade plays a very important part to the thickness of material we're cutting. If you remember, I said there's different bores. Here on this 285, you will see that particular blade is made into a 32 millimeter bore and also 40 millimeter bore. So, you know, you could order 285, but if you have a 32 millimeter and don't tell us and you get a 40, it's not going to work for you. So, but this is a chart for thicknesses. Our next chart is, say you're doing tubing. So you can take your wall thickness of your tube and then figure what millimeter blade you have, and then that will tell you what the actual tooth blade you actually, how many teeth you actually need on the blade to make it work. So again, these charts are available for you, easy to read, and you know, I'd advise you, if you're getting into the circular, make sure you have these charts. This is the most important chart. So when we're looking here right now, pick your type of steel. This is where you're going to get all your parameters. And a lot of saw every saw is a little different. So what I mean by that is some saws you got to enter a feed rate per minute per second. Some might be minute per minute. Some of them you just enter a tooth load that you want. Everyone's a little different, but you can get all the information off of this chart. We're going to give you your tooth load, which is up here in inches, either in metric. You find your blade diameter that you're using. It'll tell you exactly the speed to run. I also want to see on your mister. For example, if I'm cutting low carbon, I'll be at 5 to 7 seconds a drop. But if you notice in stainless, I have 1 to 2 seconds. So I'm putting a lot more coolant onto the blade on stainless than I am in low carbon. And all your formulations are down here to figure out your different feed rates and stuff that you would just plug right off of this chart. So basically, if you have, you know, a need in circular sawing or want to talk to somebody, we have, you know, reps all over the United States. There's, you know, there's 5 of us that's covering the area. We got Ren that does saw blade specialist that can work with you. You can get your charts from any of them, and they can help you.